Welcome to Amfer 2. Today's session is going to address the manufacturing of oxygen cylinders. In previous session we have seen about the oxygen generation plant, and today it's going to cover different manufacturing process, materials, different components in the oxygen part of oxygen cylinder assembly, and many things which can give a good intro for you to read further, understand further. I hope it's going to be very interesting in the present scenario. Let's move on to the presentation.
Manufacturing of oxygen cylinders. So first let's understand the material being used. A lightweight chrome MOLY steel or aluminum alloy or a composite. The objective is to go as lighter as possible, at the same time retaining the strength and toughness required to withstand the high pressure. So generally 18 feet long and a log shaped cast billet is used, though the size of the cylinder can vary as per the capacity and the requirement, application requirement. So the cast billet through a conveyor belt and made into a slang. So a backward extrusion press die is used. Then it is taken through a swaging process where the open end of the shell is heated and forced into a closing die to close the open end of the cup. Thereby the seamless cylinder shape form is finished, completed. So then comes the heat treatment and artificial aging. So the heat treatment is initiated, done through a solution furnace. The alloying elements of the aluminum are put into the solution, and the HT happens at 1000 degree Fahrenheit. Then if it is an aluminum alloy, it is heated about 350 degree Fahrenheit. Allowing elements to precipitate out of the solution. A cylinder that has completed both heat treatment and artificial aging can be labeled to a T6 temper. So artificial aging is done to achieve a T6 temper. If it is a normal aging, it can go up to only T4 temper. So then comes the neck configuration, and it is achieved through a milling machine and under the direction of a computer aided design CAD software. For example, it can be AutoCAD or Pro or whatever it is. Different software can be used. AutoCAD is being a very simple software. And then a hole is milled in the center of the cylinder's neck. The top surface O-ring gland and threads are machined into the cylinder using a form tool. Then comes the identification marks on the cylinder, which includes the name and chemical symbol of the gas, product specification, hazard warning, cylinder content in liters, what is the capacity. Identification marks are stamped onto the tank via pneumatic stamper. Then you can put the serial number, manufacturer's name, and the manufacturer date of the tank and the service pressure. Then the valve, which is very important, which is undergoing a very regular use. The bronze or brass are normally used for metal cap to protect the cylinder. Cylinder to be turned on and off and required for the connection to yoke assembly on anesthesia machine or to a regulator to refill the cylinder. And there are two types of valves in use. One is a packed valve and another one is a diaphragm valve. So for a packed valve, the stem is sealed by resilient packing like Teflon, and for diaphragm valve that separates upper and lower stem. Lower stem shuts or allows gas flow through the valve. Pin index safety system. So generally the cylinders and the cylinder and the valve are made in such a way like it should not match with a wrong connection. A unique configuration match to eliminate connection of the wrong cylinder to the equipment. Two holes in a specific positions on the cylinder valve below the outlet part. And the holes in the cylinder valves accept pins 4 mm diameter by 6 mm long. The cylinder can only be connected to a yoke or a pressure regulator with a matching pair of pins. So that's a safety system. Valve outlet connection for large cylinders. Valves of large cylinders of medical gases have threaded outlet often called as bull nose valve, and valve is spindle type and has a 5/8 inch female outlet where a regulator is fitted. Then comes the color coding of cylinders. Our focus is on the oxygen cylinder, but this chart gives the different color coding for different gases: oxygen, nitrogen, normal air, argon, similar. So in India it is a black body and a shoulder white is oxygen cylinder. And regarding the periodic testing of the cylinders, mainly the cylinders are expected to have a longevity of 10 years for the steel cylinder and 5 years for the composite cylinders, and a hydraulic test is done to measure the cylinder's elasticity. It has to withstand a high pressure, so connected by a thread to testing unit, filled with water and measured by gauge, isolated and cylinder pressurized to 240 atmosphere. The pressure is released and gauge open. The cylinder should stretch less than 0.02 percentage. A tensile test is done. A flattening test is done by keeping it between two compression blocks. Then a refilling test is done with giving a higher pressure, say around 2000 psi. So the expansion should be within the specified limit for 30 seconds of testing time. A bend test is done by making a strip out of it. So with this, we are concluding the summary about manufacturing of oxygen cylinders, and I'm sure there is a big demand in the market. Many places are facing severe shortage of the cylinders, and hope this is a very good information to begin with a similar venture.
How was the presentation? Was it informative? Please do share your comments, opinions, suggestions. Sure, we are very much eager to address your points, queries, discuss further. Thank you.